This partial's project objective was to find out the angular velocity and angular acceleration, as well as the tangential acceleration of a fan through the measurements we could get with a cell phone's accelerometer. The main process was really simple. We just needed to attach a cell phone to the fan and then start to spin it, and the cell phone would collect data with the accelerometer, and we could process those datums in the computer. It was really not that hard. We just needed three main formulas to to find the datums we wanted, because the cell phone gave us the radial acceleration, and with that, through three simple formulas, we could easily get the tangential acceleration, the angular velocity, and the linear acceleration, which was uh, really which was really easy to get through simple calculations. We could also find the number of revolutions by getting a formula in the graph and finding its integral, or the area below the curve. And the results were really interesting. The first velocity in the fan gave us an acceleration and an angular velocity of 11.17 radians per second, the angular velocity. Number two gave us 11.6 radians per second, and number three gave us 12.2 radians per second, which means that the difference isn't that really big. So that was pretty interesting data. The recommendations would be mainly to give the to attach more weight to the other to all the fan, so that it isn't really that irregular and the measurements are more clear. And we would also like recommend to use MATLAB instead of Excel, because it gives you more freedom of it has more formulas and more ways to find out the datums you want to get. Finally, the conclusion is that we as humans, we think that the velocities in the fans are really different, but once you measure them, it's not really that different. What changes more is the acceleration rather than the angular velocity itself.